Hey guys, let's start with solving question number 55. That is, by using Leibniz theorem, we have to find the nth derivative of 1 minus x square into y2. First, understand that if we are taking nth derivative of y, then we are writing yn. If we are taking nth derivative of y1, then we are writing it as yn plus 1. If we are writing nth derivative of y2, then we are writing yn plus 2. So here this is a given function, and it is a product of two functions. We are assuming this function as v and this function as u and this function as v, because we know that we are choosing v function such as whose derivative vanishes as early as possible. So 1 minus x square, it is in the form of polynomial, so its derivative vanishes in the next 2 to 3 steps. So we are taking v function as 1 minus x square. So let's start using Leibniz states. Leibniz theorem is, if y is u into v, then yn is equal to nth derivative of u into v function as it is, plus n into n minus 1th derivative of v first function, plus n into n minus 1th derivative of u into first derivative of v, plus n into n minus 1 by 2 factorial into n minus 2 derivative of u into second derivative of v, and so on. So let us try to apply this. So we are taking first nth derivative of function u, that is nth derivative of function y2 means yn plus 2 into second function as it is, plus n into n minus 1, that is yn plus 1 into first derivative of this function, that is minus 2x, plus n into n minus 1 by 2 factorial by just using this formula, into yn minus 1 yn minus 2th derivative of y2, that is yn into second derivative of this function, that is minus 2. No need to write next step, because in next step derivative of minus 2 becomes 0 and it all term get vanishes. So our final answer is 1 minus x square into yn plus 2 plus plus n into minus 2x yn plus 1 plus n into n minus 1, this 2 factorial, that is 2 and minus 2 will get cancelled, so only remains is minus of yn. So this is our final answer. Next question, that is question number 56. In question number 56, we have to find the nth derivative of x, y, n. Again we are choosing this function as a u, this function as a v, because derivative of x vanishes earlier. So by Leibniz test, nth derivative of this function is nth derivative of u function, that is yn plus 1 into second function as it is, plus n into n minus 1th derivative of y1, that is yn into first derivative of x, that is 1, and no need to write the next step, because in next step all term get vanishes. So this can be written as x into yn plus 1 plus n into y. So this is our final answer. Next question, that is question number 57. In question number 57, it is given that if y is equal to sine inverse of x, then which of the following relation is true? And there are 4 options. So options are 1 minus x square into y2 plus x y1 plus y is equal to 0. Second option is x square y2 plus x y1 plus y is equal to 0. Option C is 1 minus x square y2 minus x y1 is equal to 0. Option number D is 1 plus x square y2 plus x y1 is equal to 0. So we have to find out the correct option. So here it is given that y is equal to sine inverse of x. So we are first finding its derivative, that is y1. Its derivative of sine inverse x is 1 upon square root of 1 minus x square. So if we can square on both sides, So by squaring we will get y1 square is equal to 1 upon 1 minus x square. So just rearranging the term, we will get 1 minus x square into y1 square is equal to 1. So this is our first derivative. If we differentiate this function again, then we will get obviously we are choosing this as a v, this as a u, because we know that we are choosing a v function such as whose derivative vanishes as early as possible, and 1 minus x square is a polynomial, so its derivative vanishes earlier. So differentiate it one more time. No need, actually here no need to apply the Leibniz test, because options are up to only second derivative. So if we differentiate this again, then we will get derivative of first function, that is minus 2x, second function as it is, plus first function as it is, and derivative of second function, that is 2y1 into derivative of y2, derivative of y1 is y2 and derivative of 1 is 0. So this can be written as 2, we can cancel 2, so we can be written as this as 1 minus x square. We can cancel 1 y1 also, so we can write this as 1 minus x square into y2 minus x y1 is equal to 0. So this is our final answer. Thank you. Next question, that is question number 58. We have to find the correct relation. It is given that y is equal to a cos of log x plus b sine of log x. So we have to find the correct option. So first understand that I am not going to write the option this time. So just understand the what steps we have to follow. So first step, because all options are in terms of y1 and y2, that is we have to differentiate this function up to second derivative, and all the terms are only in terms of y1, y2, y and x. So first differentiate this function with respect to x. So we'll get y1, that is a derivative of cos is minus sine of log x, and derivative of log x is 1 by x, plus b derivative of sine x is cos x, that is cos of log x, and derivative of log x is again 1 by x. We can multiply x on the right side, so we on both sides, so we will get x y1 is equal to minus a sine of log x plus b cos of log x. If we differentiate this function again, then by using product rule, first into derivative of second plus second as it is derivative of first, first into derivative of second plus second function as it is derivative of x is 1. So this becomes x y2 plus y1, and this is derivative of sin x, again a is constant, derivative of sin x is cos x, so this becomes cos of log x, and derivative of log x is 1 by x, plus again here b is constant, derivative of cos is sin minus sin x, and this log x as it is, and derivative of log x is 1 by x. So multiply this multiply x on both sides, so we will get x square y2 plus x y1 is equal to, we can take minus as a common, so this becomes a cos of log x plus b sine of log x. So this can be written as x square y2 plus x y1. Observe that in our bracket there is a y function, so we can write this as a y. So our final answer, just by rearranging the term, we can write it as x square y2 plus x y1 plus y is equal to 0. So this is our final answer. Next question, that is question number 59. In question number 59, again we have to find the correct relation. It is given that y is equal to e raised to the tan inverse of x. I'm not going to write the options here, so just observe the steps. So, and all the options are only up to the first derivative, so we have to just rearrange, we have to just differentiate and rearrange the terms. So differentiating on both sides, so we will get y1, that is first derivative, y1, and derivative of, we know the derivative of x is e raised to the x is e raised to the x, that is e raised to the tan inverse of x, and derivative of tan inverse of x is 1 upon 1 plus x square. So this can be written as 1 plus x square into y1 is equal to e raised to the tan inverse of x. So but e raised to the tan inverse of x is nothing but our y function. So this can be written as 1 plus x square into y1 is equal to y. So this can be written as 1 plus x square into y1 minus y is equal to 0. So this is our correct answer. Next question, that is question number 60. In question number 60, it is given that if y is equal to e raised to the a sine inverse of x, then which of the following relation is true? Here all options are up to first derivative, so just understand the steps. So differentiate this function with respect to x, so we will get e raised to the a sine inverse of x as it is into derivative of a sine inverse of x. A as a constant, so we can write constant as it is into derivative of sine inverse of x, that is 1 upon square root of 1 minus x square. So this can be written as 1 square root of 1 minus x square into y1 is equal to a, and this function is y, so we can write this as a y. So this is our final answer. Next question, that is question